What's up everybody and welcome to a new video. And in the previous video we have generated our toy data and then we have built the base case of the post-pruning function. So now we're gonna enter this recursive part here. So therefore obviously we need a deeper tree that has more than just one layer. So let's simply create that. So we're gonna replace this true here with another dictionary, and here we simply say y is smaller or equal to 5, and then the yes answer, let's say, is true, and then the no answer is false. So this is now our new tree. So let's plot it to see what it looks like. df train and then the tree. So now we have this decision boundary here where we then check if y is smaller or equal to 5. If it is, then it's true, otherwise it's false. So it's going to misclassify all those dots here in this area as being blue, even though they are orange. So ideally then we would then post-prune, or we would prune this decision node back to a leaf that again just says true. Okay, so let's see how we do that. So the first thing that we need to do is to filter our data frames, and that's because, as you may remember from the video where we talked about the theory of post-pruning, here for each decision node, or for each stage in the tree, we only want to look at the respective data points in the training data set and validation data set. So we only want to look at the points based on the questions that we need to ask to get to this stage. So for this example here, we only want to look for instance, at data points where x is bigger than 5 but smaller than 5.4, and where y is then bigger than 7.5. So now when we run this function here, the base case here will be not true because we have this dictionary. So then we go one layer deeper into the tree. So therefore then accordingly we need to filter the data frames. So for this, so that we then have for this yes answer here only the data points where x is smaller or equal to 5, and for the no answer where x is bigger than 5. So therefore obviously then we need this question, or we're gonna filter those data frames based on this question here. So let's print that out again. So this is just a string. So if we then split it, then we get the different elements of this question. So let's say dot split. Now we have those 3 elements, and let's store them in respective variables. So the first one here is the actual feature. Then we have this comparison operator, which we don't need, so let's just use an underscore. And then the last element here is the actual value. And now we can use those elements to filter our data frames. And the way that this works is that we say, for example, df train, and then brackets, and then we only want the values where df train of that respective feature, so in this case would be then x, where those values are smaller or equal to the value that we have. And since this value here is a string, we're gonna transform it into a float. So if I now run this, then we only have data points in this data frame where the x is smaller or equal to 5. So this would be then the data frame for the yes answer of this question here. So let's store this data frame in a data frame called df train yes, and then we do the same thing for the no answer. So let's just copy this and then paste it, and then we're going to say no, and here then we obviously want the values where, or only the data points where the value is bigger than this value from the question. So this is how we're going to filter our data frames, or how we're going to split them. And now we need to do the same thing for the validation data frame. So to not actually have such repetitive code, let's use this code and put it into its own function. So let's call this function simply filter data frame, and we put in the data frame and the respective question. So let's copy the code or paste the code, and then let's replace the df train just with the df here, there, and then here as well. Whoops. And then we have df yes and df no, and those are what we want to return in this function. So df no. So that's our filter data frame function. So let's call this here. So we're gonna then say df train yes and df train no equals filter data frame df train and the question, and then the same thing for the validation data frame. So df val yes and df val no equals filter df val and question. Okay, so that is that. And now let's think about what we want to do next. So if we run this function, then here again on this tree here, we don't run the base case. So then we filter the data frame, and then what we want to do is we want to check what are those yes answers and no answers. So, and then if they are a dictionary, then we want to recursively call this post-pruning function. Otherwise, if they are a leaf, then we don't do anything with that. So what we're going to do here is then simply we say if is instance yes answer a dictionary. So if it is another decision node, then we want to call this post-pruning again on this yes answer. So we're going to say post-pruning yes answer, and then we put in the training data frame yes, and then df val yes, and then we do the same thing for the no answer. So let's copy this, paste it, and here let's indent the return statement, and then we're going to say if is instance no answer here as well. Then we call the post pruning on the no answer, and then we obviously use df train no and df val no. So now let's think about what we actually then want to do with the output of this function. Therefore, let's again run it through. So we're gonna call this function on this tree, and in the first call, the base case is not true. So we go into the recursive part, filter the data frames, and then we check if the yes answer is a dictionary, which in this case is true. So then we call the post-pruning function a second time. And here in the second time, the base case is true because both of those elements are not a dictionary. So then we're gonna check if we should keep this decision node or not, or if we should replace it with a leaf. And in this case, then we would replace it with a leaf because we don't want this decision boundary here. We just want a true here. So in the second call of the post-pruning function, we then return the leaf here, which then would be true. So here we get a leaf or this true value. And what we then want to do is now we are back in the first call of this function. So we are looking at this whole decision node. And then what we want to do is we want to replace this yes answer, the decision node of the yes answer, with the leaf that we got from the second call of the post-pruning function. So that's what I mean, that when that recursive functions are always a little bit complicated. So you really have to think that on your own, through on that. You have to really think that through on your own to really understand what's going on. So what we then want to do is simply want to replace this first element in this list here of our original tree. So what we then do is simply we say tree brackets question. This way then we get the this list here, this list, and then we want to replace this first element here. So we're going to use, say, then again, brackets 0. So that's what we do, and then we do the same thing for the no answer, only here obviously we take the second element. So this is how this function should work. So now let's run this cell, and now let's run this post-pruning function on this tree here. So what we then should get is our original tree, where we then replace this decision node with just a true. So let's see if that's the case. So we're going to say post-pruning tree df train and df val. So let's run this, and as you can see, we get this original tree, or our original tree, where we just ask the question is if x is smaller or equal to 5. So now we are almost done with our post-pruning function, but we need to make one more change, or actually 2 more changes, but let's start with the first one. So now currently we are only checking if we should keep a decision node only once for this question here, where we ask if y is smaller or equal to 5. But obviously we want to check if we should keep the respective decision node for all the decision nodes in the tree. So we have to run this code here again after we checked here if the yes answer or no answer are a dict. And just to see that we actually really have to run this code, let's here print the question. So this way then we can see what decision nodes are actually checked, if we should keep them or not. So let's recreate this tree, and then let's run this here again. And here you can see we are only checking this y question. So therefore then we need to run this code here again in our function. And so that is not just so that we don't have so much repetitive code, let's again put this code here in its own function. So let's call this function pruning result, and here we pass in the tree df train, so the same things that we pass into the post pruning function, so df train and df val, then paste the code. So this is our now pruning result function. So this is then what we are gonna return here. Return pruning result of the tree df train and df val. So in this function then we simply call again at the end of the post pruning function. So let's replace this here. And now we should we check what the pruning result is for both decision nodes in our tree. So to see if that's the case, let's here print the question. So we're going to say tree keys. So now let's recreate this tree here. Let's run the function like this, and now let's run this post pruning function on this tree here again. And now you can see first we are asking the question is y smaller or equal to 5, and then we ask if x is smaller or equal to 5, and then we get our pruned tree here. Okay, so let's delete this print statement again, and now we need to, or we want to do one more change, namely that change has to do with how Python handles mutability. So to see what I mean by that, let's print this tree before we do the pruning, and let's use the pretty print function. Okay, let's set the width to 20. Okay, so this now is the tree that we have. And then afterwards we run the post-pruning function. So let's put the result of that into a variable called tree pruned. And then let's also print that pruned tree. So initially we have this tree, and then when we prune it, we have this one. And now let's print out our original tree again. So let's just copy this here and then paste it again. So we should then have again this tree here, but if I run this, you actually see, let's make it like this. You actually see that we now have already this pruned tree. This is because of how Python handles mutability. Namely, what happens is that when we when we replace this element here in this list of the tree of the dictionary, then we're not just replacing this element for this parameter here, but we're actually replacing it for this variable that we have created outside of this post-pruning function. So because it has the same name. And to now get around this, because what I would like to be able to do is I would like to compare then the tree, the original tree, with the post-pruned tree. So therefore I want to have both trees. So to do that, what we're gonna do is within this function, are we not going to change the elements of this list here by specifying them, but instead we're going to create a new tree. So here we're going to then say this is simply the new yes answer, and this here is the no answer, and then afterwards we create a new tree. So we're going to say tree equals a dictionary where the key is the question, and then we have a list where the first element is the yes answer and the second element is the no answer. So this way we then avoid this problem of this mutability. So let's create this tree again. And now if I print here the tree, then we have that tree, then we prune it. So then we have this pruned tree. And now let's print the original tree again. And as you can see, it's still the tree that we had before the post-pruning. So now we are finally done with the post-pruning function. So now let's check, and it should be working. So now let's check if it actually works for this overfitting tree that we've created in the previous video. So let's cut this cell here, paste it, and now let's here for the validation data, let's actually print the pruned tree. So we're going to say, so we have to first create it. So we're going to say tree pruned equals post-pruning of the tree that we here create, then df train and df well. So let's now, if I then run this, we should have this overfitting tree in this first diagram. And in the second, we should just have a tree that checks, or that splits the data here in half and checks if x is smaller or equal to 5. So let's run this to see if that's the case. So here's our overfitting tree, and here is still the overfitting tree. And that's because obviously we have to put the prune tree in the create plot function. So let's run it again. So again, here is the overfitting tree, and here now is our pruned tree, where we just check if x is smaller or equal to 5. So let's actually also print it out to see if that's really the case. And as you can see here again, we have this tree. So our post-pruning function seems to be working. So now just to check it a couple of times, let's comment out here the random seed. And then we're not going to use this specific outlier, but instead we're going to create, or we'll use another parameter of this function, which is n random outliers. So there we can specify how many outliers there should be in the training data. So let's say 5. So now if I run this, now we have here 5 outliers, and the algorithm creates such a tree. So now let's look what the pruned tree looks like. And again, it's our basic tree where we just ask this one question where x is smaller or equal to 5. So let's run this again to see it a couple of times. So here now we have this tree, and again it's pruned back. Let's run it one more. Now we have such a tree, and again it was pruned back, and just one more time. Now we have this tree, and again it's pruned back. So our post-pruning function seems to be working now. So now what we're gonna do next is we're just gonna make some small changes so that we can also use this post-pruning function on data where we have categorical variables, because right now we only have x and y, which are both continuous. And then another change that we're gonna make is so that we can also use the post-pruning function for for machine learning tasks where we do a regression and not a classification like we have here. So this will be the topic of the upcoming video. So thanks for watching, and hopefully I'll see you in the next video.